Welcome to VW 12.2. Today we're going to finish up chapter 12, which is pretty short, by starting with this concept, the determinant. So the determinant is an operation in the topic of matrices. This is our general topic, or matrix for singular. And a matrix is basically like a collection of numbers, like this. A determinant is when you take this collection of numbers and put these straight bars. It kind of looks like absolute value. And it's simply an operation that's AD minus BC. So think of it like multiplying the diagonals and then simply subtract them. So that's really all you need to know for this first part. So for this one, we're going to say this is 3 minus negative 12. That would be 15. For this next one, this would be 18 minus negative 4, which is 22. It's a pretty easy operation. And again, notice that this right here, those vertical lines, it means take the determinant. Now the reason we have that operation is for this. It's called Cramer's rule. So on the side here, I'm going to give you kind of the basics of Cramer's rule. Cramer's rule is a very interesting way to solve a system using that skill I just showed you. So here's a generic system. So I'm going to show you a generic system here that utilizes Cramer's rule. AX plus BY is equal to E, and then CX plus DY is equal to F. So basically, Cramer's rule is going to utilize this determinant into three pieces. So there's your main determinant D, which is simply A, B, C, D. So notice I just took all of these coefficients and drop them in right here. And then there's going to be your determinant D sub X. And then that determinant is pretty interesting. It looks like this. EF BD. And then there's one more determinant, D sub Y. And this one is going to be AC and EF, like that. Now it looks pretty random. Now it's important to understand kind of what's happening here. If you look at this A, B, C, D, this is like your X column, this is your Y column. So that'll help us understand what's happening. So our D matrix is pretty straightforward. It's simply the X column and Y column, copy and paste. Now the D sub X one, look at this. When it's D sub X, this X column got replaced. So X, you have to replace with these two things. So that's why you see a EF right here. And then in the D sub Y, notice your Y column, that is then getting replaced with your EF. Now once you have those three things calculated, the rule states that D sub X over D, that is equal to X, and D sub Y over D is equal to Y. And then you get your solution XY. So it's a pretty interesting way to generate the solution to the system. So I'm going to show you how to use this right over here. So our D matrix for this one, just grab everything, 3, negative 2, 6, and 1. Our D sub X, so your X column, this one, gets replaced with these two things, 4, 13. And then you're going to leave the Y column alone. So that's negative 2, 1. D sub y, you're going to change your y column for 13, leave the x column alone, 3 and 6. Now we calculate. So this is going to be 3 plus 12, which is 15. D sub x is 4 plus 26, which is 30. And d sub y is 39 minus 24, which is 15. Now apply the rule. Just do dx over d. So dx over d, that's 30 over 15, which is 2. And then dy over d, that would be 15 over 15, which is 1. Therefore, the answer is 2, 1. And that's how you use Cramer's rule. So a pretty cool use of this new operation called determinant. And the final step is a 3 by 3 determinant. So notice how this rule I gave you, this is good for 2 by 2. Good for 2 by 2, meaning 2 rows and 2 columns. That's what this is saying. 2 rows, 2 columns. Now, when you get to PCH, you're going to learn a more advanced way of doing this. But in RH2H, I'm just going to show you the really simple way to do this. All you do is you're going to copy and paste these 2 columns right next to the matrix. 3, 4, 8, 0, 6, negative 2. So again, notice I just took these 2 columns, wrote them over here. So again, grab those, put them over there. And then I'm going to move this actually, make it a little bit nicer. So once we're here, we're going to apply the same idea. We're going to use the diagonals like that. And notice how there are 3 diagonals. 1, 2, 3. We're going to multiply those just like we did in the 2 by 2 here. So notice how I did 3 times 1, that's your 3. So we're going to do that 3 times here. So 3 times 6 times 3, that is 18 times 3, which is 54. Then plus 0, and then plus, that would be 8. And then, notice how in this other one, this diagonal right here, this diagonal made negative 12, but because we're going up, we see a negative here. So it's the same idea. We're going to go here, and we're going to be going from the bottom up like this. And notice how there are, again, 3 of them. 1, 2, 3. And because we're going in the upwards direction, we're going to subtract all these values. So minus whatever this number is going to be, that would be negative 48, minus the next number, which would be negative 12, and then minus the last number, which is 0. Now we're going to evaluate. So that's 54 plus 8 plus 48 plus 12. That would be 62 plus 60, which is 122. So that's how you do a 3 by 3. So in short, if you guys like a formula, I'll show it to you right here. So essentially, if this is our 3 by 3, again, you copy and paste these 2 columns here, like so. And then you're going to go make your downward diagonal from the top, AEI plus BFG plus CDH. And these, again, they're going down, so we keep them positive. Then the next ones, we start from the bottom left and go up. And you'll notice these are going up, so we're going to have to negate these values. So then we're going to put minus GEC minus HFA minus IDB. And that's it. So that would be your determinant of a 3x3. And again, when you go to PCH, you'll no longer use this method. You'll use a more advanced method. But for our class, this will be more than enough.